Hi, I'm Rifat Jahan, and I'm going to present today our Azure Synapse after scraping automation. Today I'm going to cover basically two parts. So one part is about how we can automate the scraping, and the second part is how we can use Azure Synapse to actually integrate our different sources and work on them and build up our analytical dashboard, integrated analytical dashboard. The problem today I'm going to solve is a pretty simple one. And I am actually showing a broken down version of a very large problem that we are facing in our organization. And this is a very simplified version of the actual problem actually. So let's have a walk through it. So the thing is uh, in my company we are actually all are developers, and we have to give our hours on a daily basis. We have many projects on our plate, and we have to give task wise hours separately. So what we do is we actually maintain a PM Scrum, and on that for each of the person, they mention their project name, and on the according to the project name, they mention the tasks. If I show the format, it's something like this. So the person says his name. On the date, it's been updated, the project, and the tasks, and the hour he spent on it. This is done on a daily basis, and the PM have to give this whole entry. As you can see, it's a pretty cumbersome process, and it's a bit hard to manage. So what we came up with is something like this. As our organizational wide, we actually use Teams to get our inputs, and every team member is pretty much comfortable with the Teams. So at the day end, we actually can put our updates something like this. So this is a very simple and straightforward way. Just mention update and write down our projects and its details. If I try to elaborate a bit, so our format is something like this. What we do is at the very end of the day, we mention a tag that is called update tag, and on that we mention our project name, how much time we have spent, and after our spending hours, we mention which the tasks we have done so far on that particular project, and mention what type of work I have been doing. So this is a generic practice, and all of the team members, almost 10 to 12 team members, follow this pattern and give their updates accordingly. For confidentiality reason, I can't show everything, but I'm actually trying to show what kind of format we are following. As you can see, every member actually gives this kind of update, and we actually scrape this the whole thing from the web by using Puppeteer, and we are using Node.js application. So for that, and at the end, we are getting a CSV file. Simplified format to CSV file, and from here we are actually processing the whole thing. I'm not showing the automation process, but showing the building blocks, what we have used to build it. So this is the Teams web platform, and it is shown on the web, and the structure is something like this, very simple structure, and on every message there is a common structure that we follow. There is a UI box. The UI box is the whole box thing where all the messages are kept, the username, time, the update message, stuff like that. So we grab the whole thing, Then there is a UI chat message header. The header we get the username and the time. On the time tag we get the time, and on the user UI chat message header on a span we get the username. And then there is lastly the message content. On this section we get the whole message content, and this message content is sorry and this message content is actually a set of HTML tags, so that in Teams we can actually write down HTML at our free will, and the whole message is actually shown in this format, and we are actually grabbing the whole thing so that we can actually work on these messages later on. Okay. When all things are collected properly, we get this final CSV result, and with this CSV result, we actually proceed on to our analysis. Okay, I'm just showing a very scaled down version of the actual problem. So I'm showing only one project problem for the whole team, and all these names are actually fictional. So this is just a scaled down version of the actual problem. Okay, now we have the data that we wanted to process. When we after scraping automation, when we get the data, we actually move this whole thing to Azure Synapse. And what we do in Azure Synapse is we use the basic services. And today I'm going to show you how can you actually start a very first step to get up and running with Azure Synapse, and how can you explore notebooks to actually process your data there. Okay, so let's have a overview of Azure Synapse. What can we do there? So in Azure Synapse, what we are doing is we can actually integrate multiple data lakes. We can actually have multiple data sources there. It can be many blob storages, and we can aggregate those data sources there and work on them. And then in Azure Synapse, there is develop notebooks, so we can actually use Jupyter notebooks, unlike other just like other platforms. And as we know, there are many different sources there, and there are Databricks, Snowflakes, and many heterogeneous data sources and data managing platforms that actually are very silos on their own nature. But opening up a way forward to actually aggregate all of the data from these sources. So we can actually integrate data from Databricks if there is a data, and if we have some other platform data like in AWS. In AWS S3 storages, we have many data like another data lake. We can also integrate those things here. We shall actually see some of the examples here. And there is dedicated and on-demand SQL pools, so that we can actually can run our SQL queries on outcome we need. We can actually run on them, and on our execution basis, we actually get charged. So we can actually scale down our cost drastically, and actually go through our experiments way beyond our typical limits. Like if I share an example, like for a terabyte spent, and this is very much negligible. So we can actually harness this power and actually can analyze our data more frequently. And Synapse is actually paving us the way for integrating various sources, so it is very helpful for us. And at the end, we can actually integrate the Power BI and Power Apps, so that we can actually visualize the analytical reports. And there is also a service called the integration, and on the integration part, we can actually integrate the notebooks, process the data, and also can integrate the SSIS processes that we have run for our previous steps. So all the ETL that we have done previously on the SSIS platforms, that is also integratable in this platform. So Synapse is actually helping immensely. And this is pretty much the summary, but what I have said so far is actually only these 4 steps. So Synapse is actually helping me to aggregate heterogeneous sources. I can aggregate different sources and process on those data on the fly. On the data integration, I can actually integrate my data and make and align the pipeline as long as I like, and I can define the pipeline which from which end to end the processing will be done. It is actually defined here. Then there is the processing steps. In these steps, I can actually process the data according to my need. And if I want, I can actually spin up Spark containers and easily can walk through terabytes scales of data within some seconds. And there is the visual capabilities where I can actually visualize the whole thing in a Power BI dashboard, or if I wanted to actually transfer the visualization to any other tool, it's also available there. I can just integrate, and I can just integrate the data and plug and play there. The warehousing capability and the computation capabilities are all there. We just need to use them. And if I walk through just the services that Synapse is actually integrating, these are the services at a glance. So in Synapse, so we are doing the data exploration. Artificial intelligence means we have built-in models and built-in notebooks that we can actually use to walk through generic industry-based practices. And there are some machine learning models, built-in models there. We can actually utilize them to actually explore and analyze our data as well. And I shall show some of the templates there, but not a particular example, but we'll show some of the templates that is built in Synapse. Okay. And we can actually manage and maintain the data warehouses and SQL servers as well. So and we can build up the real-time dashboard reports on the Power BI. So and data integration is actually built in there. So a whole data ecosystem and a data management perspective is built in there in Azure Synapse. I'm trying to go a bit fast, but if you guys have any question, please feel free to ask them on the Teams. I will try my best to answer them. So let's make our very first Synapse account there. I have just took some snapshot along the way so that I can just explain how we can actually get started with Synapse. So we for this purpose we must have to have an Azure account, and on this Azure account we are actually spinning up Synapse Analytics so that we can have some hand-on experience of what is Synapse is offering to us. So on Synapse, what we do is on the Azure Marketplace, we just search for Azure Synapse Analytics, and we get this service, and we actually select it and spin it up. On the next step, we shall be redirected to this dashboard, and on here we can just create the service, and if we create it, will create a workspace for myself. Just a moment. Sorry, I had to leave. Okay, so I'm continuing from the rest. So here I was creating the Synapse workspace. So on the Synapse workspace, what we are doing is we are just started to create the workspace, and after this step, I will be asked for some generic questions like what will be my subscription on the Azure. I have selected my subscription. If I have a resource group, I can select that resource group, and then there is a managed resource group account. On this resource group, managed resource group, all my resources will be stored, and I have to give a workspace name. This name have to be unique. Based on this name, I actually will get my access to the workspace so that I can work there. I can select the region, and there is a data lake storage generation. I will select the latest one, and there are the two more options, and that is the account name and the file system name. Basically, file system name is the blob storage, and the account name is the data lake storage account name. So I have to have a data lake storage account and the file system account, and I just created both of them on the next two steps. And after I have created both of them, they are actually linked here. And so creating a Synapse workspace, I have to have this data lake storage, and also have the file system storage, file system blob storage. So I have created both of them, and then I'm proceeding to the next step. So the security. On this step, it will ask me for SQL Server creation, and I will just create it. And then yeah, if I want to encrypt some of my database SQL database servers, I can do that as well, but I haven't done it. And by default, it is disabled. But according to your need, you can change it. Then there is the networking. If you want to manage a virtual network on your own way, you can define it. You can assign more privacy and make it a private network, but it's on your own accord. I haven't done it as it is a demo purpose only. So I have just disabled it and proceed to the next one. And on the next one, as I mentioned before, it actually shows me an estimation how much it is going to cost me. So per terabyte, it is going to cost me about 5 USD. So I'm okay with that, and I'm proceeding. I have very small set of data, so it won't charge more than a cent, but still it is forecasting me how much it is going to cost. So anyway, I'm going to just create my workspace. I'm just pressing create, and I'm going to proceed. Okay, so it will take some time to actually proceed the whole thing, and it will actually help me to create all of the dependent dependent tools. And when it's been created on the resource group, I will get my workspace. And if I click on my workspace, sorry, if I click on my workspace, it will give me a link to connected to my Synapse Studio, and if I click it, a loading screen will appear, something like that. And after it's been loaded, it will show me this panel, and from this panel we'll explore some of the stuffs right now. And if I focus on the dashboard on the left side, I have just zoomed in the dashboard in here so that I can actually talk about these things. So there are these particular tools that we are going to see right now. So on the data, we can actually manage our data sources. It can be on these data lake platforms, and also other data sources as well. We can actually integrate those there. On the development, we can actually select and create our own notebooks, own Power BI apps, and stuff like that. And we can actually see through our work from here and visualize our stuff to some extent from here as well. On the integrated panel, we can actually integrate the workflows according to our own will. Like we can have notebooks to process some of the stuff, for then move the data to another warehouse, or then move it to production to server, stuff like that. We can do whatever we want. In the integration server, we can actually define our own pipelines there. And after we are done with the integration part, we are actually moving on to the monitor section. On the monitor section, we can actually monitor and check out each step costs. So whatever query we are doing on this monitor section, we can actually visualize what kind of memory is spent there, and how much I'm going to be charged later on. The cost won't occur immediately, but at the month end, the cost will be there. But you can see how much memory is being consumed, or how much resources being consumed from the monitor tab. And you can actually limit your budget there from as well, so that you can unintentionally hit additional cost, or occur any additional bill that you won't be bear later point of time. So it's very handy. And from manage, you can actually see, actually you can walk through all of the things. So you can create a SQL pool, so you can create a Apache server pools according to your own need. You can manage your clusters from here. Basically on manage, you can see everything there, and you can manage your stuff from there. Okay, then let's move on to Azure Synapse. Let's have a tool. Okay. So this was the platform that I was talking about earlier on the slide. So what we can start from this ingest section, or you can see on the new, you can create your own SQL script or notebooks or data flows. You can just define and work on those or on these things. So let's start from the ingest. On ingest, you can actually import data from different sources. As you can see, there is a source, there is a destination, and you can actually define which data is going to be transferred to where. So for demo purposes, I'm showing just a pretty simple stuff. So from my storage account, I have previously created this account, and here is storage. On the storage, there is blob storage, blob containers. Yes, there on the blob storage, there is a CSV file that I have just shown you earlier. And if I import that file, I just going to import this to just another folder. That's it. This is just a simple exercise to show that ingestion is pretty much simple in here. Okay, so let's start. So I'm going to run once now. I can actually schedule it, so that actually from a source it will grab the file and ingest the data accordingly. But for demo purpose, I'm going to run this run once now. And I'm going to the next one. I'm just selecting my blob storage, browsing it. So I have just selected the CSV file. Okay. Proceeding to next. Just mentioning the CSV file structures. It is just default, but if I want, I can actually change these things as well. But this is pretty standard CSV, as I have just shown. Let me just show it once more, just to be clear. As you can see, it's just a standard CSV file and without any headers. So just proceeding with the default ones. Anyway, then I'm just moving to the next one, and this is the destination. I'm just selecting the same destination with the different folder. Just that's it. I'm selecting the Synapse folder. Thing is default. This is the task name that is going to be shown. This is going to show me the summary of what is going to happen if I proceed, and if I proceed next. It's actually ingesting the data. Okay, we are done. If I go to the Synapse again, as you can see, the data has come here. So we can actually ingest like these data sources from heterogeneous sources. We can actually get these types of data from different sources. This was just an example. Anyway, then moving on, we can actually explore the next service, I think. So we have seen some of the basics about the data. Let's see some of the basics of the develop pipeline now. Okay, so we can actually create our reports in here on the develop pipeline. We can actually develop some SQL scripts. We can just run them in here, or we can define our notebooks in here, or we can just browse. Sorry, and the Power BI report is causing some problem. No worries. I have to just reload it. Okay, on the development panel, if I create browse from gallery, if I want to browse some of the pre-built templates so that I want to work on, I can actually explore those things. So if I see Boston house price prediction, so let's just explore this example. This is a simple example where based on some criteria or some features, we are trying to predict Boston house prices, so that we wanted to know based on the region and common characteristics how much the house is going to be priced. So this is a pretty standard procedure, and I can just preview the notebook, and if everything seems all right to me, I can just open the notebook in here. And whenever I'm opening the notebook, actually I also have to attach and Apache Spark pool. Basically, this is the compute engine. You can assume this is a Spark instance that I have created earlier, and it's going to take a while to run, actually. But whenever it takes a time, let's see the manage pool. On the manage pool, I can actually create a new Spark pool. So I'm just showing the process how we can actually create a Spark pool and work accordingly. So on the Spark pool, we are actually mentioning the Spark pool name, just a test2 or something like this. We can actually name anything. The node size family, memory optimized, there are many families there available. We can actually explore those things. I think for my purpose, memory optimized was defined. Node size, we can actually define the node size. The more node we take, actually it takes more cost as well. I'm actually running out of time. Okay, I'm trying my best to make things short. Auto scale, we can actually enable auto scale, and the number of nodes, how many nodes we wanted to spin up. As you can see, the cost increases accordingly per hour, as many nodes I am actually taking. So I'm actually keeping it to a minimum, and if I create it, and it will be created, but I am not creating it as I have a previous node available. So I just showed you how you can create your own node. So this was the previously created node, and I'm going to use it. Okay. Okay, then moving on, I'm just going back to develop and explore that notebook we have just created. And as you can see, all the cells have run just for the sake of this demonstration, and we can see the house price prediction at the very end. This is the correlation of the fields, and at the very end there is a regression line. Yes, this is the regression line we are going to predict, and based on this line, we are actually predicting the house rent that are come up with their specific features. So this was the demo, and there was another part on the integration. Let me just quickly walk through there. On the integration part, I can actually define my own pipeline. Let's have a quick pipeline and see what can be done in here. I just join and actually merge up my nodes here, and I can actually, as I mentioned earlier, I can actually Azure integrate a data explorer as well. If I want, I can integrate Databricks notebooks as well. And there are Azure Insights and Azure Machine Learning as well. So all the common platforms of data platforms are actually in here. We can actually plug and play and make various combinations and integrate the data in a central place so that we can actually visualize and walk through our data properly. So this is a truly interesting thing to play with. So you can try out Synapse in here. And as I mentioned earlier, on the monitor, you can actually monitor all of the queries in here. So here are the list of the queries that I have run so far, and all all of the memories that I have used so far. And on the manage tab, as I mentioned, I can actually see my SQL pools, my Apache pools. If you are not using the SQL pool, you can actually delete it. And Apache pool, just mentioned earlier, this was created a few minutes back. If you don't like these clusters and you are not using them, just delete it. It will save. It will cost you much lesser, and these are spin up whenever you are just querying the stuff. Other than on the other times, these are automatically shut down. So this is very handy for your work. And there, as I mentioned earlier, there was a last step, that is visualize. I'm actually skipping it. On the visualize step, you can actually visualize the whole thing in a Power BI report. I am just sharing the final report. This was the final report that I generated, and in here I am actually can see my team members occupancy by project wise on an hourly limit basis, and these are the colleagues that I've been working with. So they are fictitious names, but it's showing how much time they are spending on my project. And for a single group, these many charts can be utilized, and for the whole organization, many bunch of charts can be organized like this way. But this was just a demo, so yeah. So we at the very to summarize just the whole thing. At the very beginning, we just tried to automate our whole time entry process from just the chat platform of the teams. We grabbed the data, cleaned it, and then actually analyzed on those data so that we can actually see the reports on the Power BI. So that was all from my side. If you guys have any question, please ask.
I think this was the keyword for me, right? Hello and welcome.
Thank
Next
you.
slot.
Yes, you can start, Marcus. Sorry, I took some of your time.
No worries, no worries. This can happen. Yeah, welcome to everybody of you. I think for you it's already almost close to the end of this SQL Saturday. I just woke up maybe 2-3 hours ago, so for me it's not early, but it's right after a nice breakfast on a Saturday. And I will immediately share my screen so we can jump into the session. Somebody let me know as soon as you see my screen.
Yes, yes, the screen is visible. Yes.
Thank you very much. Perfect. So welcome to Advanced Data Modeling in Power BI. I'm Marcus, and I introduce myself the way that I say I work with models. I work with data models, of course, since over 30 years. But if I tell people that I work with models, sometimes they have different things in mind. They think I work with beautiful people, but indeed I work with beautiful data models. At least they're beautiful after I worked with them, right? Because naturally, like natural data is always dirty. We have to clean it up, and also natural data models usually are not are optimized for what we need, for example, in Power BI. So before we even start with the advanced stuff, I want to make sure that everybody of you is aware of the basics. And the basics for Power BI Desktop and Analysis Services Tabula is the very same, right? Both are covered by the Vertipack engine. That means behind the scenes, there's the same tool, the same database. Hi, Hassan. How are you doing? So behind the scenes, it's the same database engine. That means everything we talk about data modeling, optimizing the data model, talking about DAX and things like that. It's the very same for Power BI Desktop Analysis Services. You can even, if you start Power BI Desktop, load data into Power BI Desktop. If you start the task manager and look on the subtasks of Power BI Desktop, you will be surprised that there's a Microsoft SQL Server Analysis Services instance running inside of Power BI Desktop. So that's the same thing. And both are optimized for a schema. So this is a model-oriented tool, and they're optimized not for any schema, but they're optimized for a star schema. That means that the storage engine profits from the star schema. That means the compression is better, and also DAX. If you have to write complex or even rather easy DAX statements, if your data model is not a star schema, this could be very complicated or even be a nightmare. And the discussion here is not about if a star schema is superior about other data modeling techniques. That's not the topic. The topic is Power BI and other services is optimized for the star schema, and if you apply this way of data modeling, then your life and the life of your report users will be easy. If you're not applying, it will be harder. And other tools, they don't need a star schema. Other tools maybe want one single table. Think about paginated reports in Power BI. Think about Tableau. They want to have a wide table with all the content in there. This has advantages and disadvantages. And for some reason, Microsoft decided for the star schema optimization here. This also means that the relationships in the star schema, they are always a one-to-many relationship, right? We have one customer who can have hopefully many sales events, and one sale event can exactly be associated with one single customer. That's the one-to-many relationship, and it's optimized for only filter directions going from one direction to the other one. So if I filter the customer, it will filter the sales, and I only will see the sales for this customer, but not the other way around. If I filter, for example, the date on the sales table, it will not filter the customers available for filtering. If you need this, you can apply techniques in the reports, but you should not make your data model be bidirectional, where the filters go in both directions, because then the model will be slower again, and there could be situations where you cannot apply the same trick again to the next table you want to join, because you end up with an ambiguous model, and Power BI and analysis services will not allow to do that. So before we even started, before we come to the advanced stuff, I want to make sure that the many-to-many relationship, you should stay away. You should not use it. Detached tables, that means tables which have no relationship, no physical relationship between one table and the other one. You should not do that. And the key value pair model, as we will see in a second, is very flexible for the application developers, but this is a nightmare in doing report on it. And this is what you should avoid, and this talk is exactly about how to utilize those situations. But I've just wanted to make sure that you don't use this talk as an excuse to model many-to-many relationships or other things. You only should use it in very special situations where you're sure, you matured, you discussed, you thought about it, and then you came to the conclusion there's no other way than, for example, using many-to-many relationship detached tables or treating a key value pair model. And this is the agenda for today. So we will talk about, or for the next 40 minutes or so, about the multi-fact model, about many-to-many relationship. In the multi-fact model, as we will see, I come up with an example about a detached table, and we will talk about what we can do about key value pair tables. It's not really a model, right? It's one table, but we'll see in a couple of minutes. So a multi-fact model means in a star schema you have a fact table, and the fact table is in the center of the star, and the dimension tables are around it. So with a lot of fantasy, I would say, you could see a star formed there. I think the term was introduced by Ralph Kimball. He had like nice ways of describing things, but sometimes I think it's confusing because I don't really see a star in the star schema. So I have my hard time with explaining why it's called star schema. But you could have like not only one fact table, but you could have several fact tables. And then some people speak about the universe and multi-fact tables because there's many fact tables. So one star, several stars form a universe. And you should, again, try to avoid this. If it's not necessary, don't build several fact tables, but you need to have several fact tables. For example, if the granularity is different. So one table is talking about like daily data, like the actual data. The Death Star schema, yeah, that's a good thing. I don't think I have this in this slide deck, but in another slide deck I call like what's the Death Star? What's the death to a star schema? Which is, for example, a simple table, a single table, or the normalized and other things. Okay, so coming back to here, so if there's different granularities, then you would have different fact tables. So one is maybe on daily data, the other one is on monthly data, for example. And at least they should share one common dimension, because if it's like really separated fact tables, which even don't share any dimensions, any filtering or any aggregation on the same entity, and then you should not put it in one data model, but just make two data models out of that. And I think, this is my prediction, there's this preview feature called Direct Remote over Power BI and Analysis Services, which is an awful long name, so I'm excited to hear about what will be the name of this feature when it's coming to general availability. So GA means when it's general available. Currently it's still in preview. The feature is in preview since December 2020, so almost 2 years. I hope it will become available soon. That means you can try it out, but it's not supported. So if you're struggling with the features, Microsoft support will not be able to help you. And the idea is that you then connect. Currently, if you have Power BI, you can only connect to one single Power BI dataset or analysis services tabular model at the same moment with the live connection. But with this direct remote, it will allow you to connect to different models. That means that you build up your own galaxy inside of your Power BI report by connecting to this fact table and dimensions and the other fact table and dimensions. And of course, you will want to keep them together, for example. So this will be an exciting feature. And as no tool currently on this planet is allows you to do such a thing, we will see how we can. We have to learn how to use models like that, to have those proxy models, for example. The use case I came up with here as a demonstration for the next demo is a budget. So think about that the budget usually has a lower granularity than the actual data. So the actual data is on daily basis, the budget is maybe on yearly or quarterly or monthly basis, but most probably not on daily basis. The actual data is on product level, but maybe the budget is on the product group level. So that's what I came up here with up here. And I will demonstrate 3 different solutions how we can do this. There's one function in DAX which is called treat as. When I first saw it, I thought this is a Greek goddess, Triatas, but no, it's treat as. For some reason, we don't use Camel or Pascal keys for in writing functions or things in DAX, so this makes it sometimes hard to read or get the idea. So treat as, or the many-to-many relationship. We will see how this works out in this, or what I prefer is the bridge table. But long story short, we will jump into the demo. So what I came up here with is a very simple model. There's one sales table, as you can see here, and this sales table contains only 4 rows. It's a really simple model by intention. I want to keep this simple so we can concentrate on the more complex stuff and still understand what the complex stuff is doing. And we can see there's a product table and there's a relationship in between, and there's the product 100 and 110 and 20 and 100. So 130 is no sales and 110 is 2 sales, and then those products are grouped, group 1 and group 2. So the first 3 rows here form the group 1, and C is the only one. So group 2 is the only one where we also have sales. The budget table has no relation to the product group, and in fact, if I jump over to the model view, you'll see here this is a more or less typical multi-fact model. So we have one fact table, the sales table, which has a dimension is filtered with the date dimension in one-to-many relationship and by the product dimension, because there's a product ID in both and there's also this date in there. The budget has a different granularity, and just to make things easier, for the sake of this demonstration, I connect this per day. So the budget is filterable on the date level, which is not typical in real world scenarios. But I just wanted to concentrate on one single complexity here, the connection between the budget table and the product table. And there is no connection, as you can see here, because I don't have a product ID in here. I only have a product group, and the product group in here is not the key there. So I could not create a one-to-many relationship, but a many-to-many relationship. And for the first way, I just wanted to stay away from this many-to-many relationship and show you what's the consequences of the current situation. If you build a report on this model, we can see I have 2 lines here. 2 lines because it's both for the month of June. Everything is in June, right? And the group 1 and group 2 is because there's 2 different product groups, right? So the group 1 consists of those 3 sales, those 3 products, 3,000 plus 20 plus 10 is the 33,000, and the 15,000 is the last one here. If you add this up, you get 48,000. Everything is fine as expected, I would say. For the budget, we get this weird situation that there's a repeating number. I mean, there could be a situation where we have for both groups the same budget, so this could be an issue or not. It's hard to tell. But if you see the total down there, we can see that there is a problem indeed, because 27 plus 27 is not 60. So something is wrong, clearly. So let's try to understand why we see these numbers here. So the 27 indeed is, if you take a look on June, of the June budget, so we have a budget for June and for July. And for June, we have a budget for the group 2 and group 3, and both of them form this 27,000. So the 27,000 we see here are those both lines. But maybe you think, wait a moment, Marcus. I mean, we are talking about group 1 and group 2 here, and then you tell us this is the sum of group 2 and group 3. This doesn't make sense. Totally with you. This doesn't make sense, but there's no filter going from the product table to the budget table. So anything I select here, anything I show here, forms a filter context on the group 1 or group 2, but the budget table is totally ignoring this filter context because this filter is not propagated between the product table and the budget table. As you could see here, there's no filter in there. So this table is not filtering the budget table. So that's why we see the 27,000, because for June, we have in June, the date is filtering, right? If I select some dates here, this is filtering, this filter is propagated to the budget table. So I see 2 times the same budget, the 27,000, because I see 2 lines with June. The filter on the group is totally ignored when it's coming up to the budget table. So what about the 60,000 here? You should keep in mind that unless we explicitly ask for that, in normal situations, the total down there is never ever the sum of those single lines. The difference between the total and the individual lines in a table, for example, table visual, is that the filter context is different. So in this line, there's a filter context on the month, there's a filter context on the group, and this is respected by the sales table, and is only partly respected by the budget table. So only the June is filtering the budget table, but not the group 1. The filter context is then different for the next line, and the filter context is also different on the total. So the total, the only difference between the total and individual lines is that the filter context is different. That means in the total, there's no filter on the month, there's no filter on the group. So that's why we get the 48. The 48 is not the sum of the 33 and the 15. The 48 indeed is a sum of all those 4 lines. And the same applies for the budget. So for the budget, if we add up the 20 plus the 7 plus the 25 plus the 8,000, this is the 60,000. So in this line, there's no filter applied on the month, no filter on the group. That means all of the lines are summed up, and that's how we get the 60,000. I hope this is clear so far. Andre makes fun. I might steal this picture, Andre. Okay. So back to that. So how can we solve this? One way would be this function treat as. So just I know it's hard to tell if I say ignore the part up there, we concentrate on this. Of course, everybody will not look on this part up there, but stay with me. We will talk about this code in a second. I just wanted to demonstrate what's the difference here. So the budget is still the 27 with the 60,000 down there. And with this budget 3 that I came up with, I can hardly solve the issue. At least we get now an empty budget for group 1. Remember, for group 1, for group 1, we don't have any budget. The budget is only for group 2 and group 3. So this sounds right. The budget for June in group 2 is 20,000. This is also right. But that's the 20,000 for group 2 and June. And for group 2 in July, we have this 25,000, which we can also see here. So this is partly better. We can also see that like the sum makes sense. The 20 plus the 25 is now 45,000 because yes, I just explained to you that the total down there is never ever the sum. It's just a different filter context, but still, we as human readers expect that this sums, the total makes sense to us, right? Otherwise, something is wrong in the system. But this still doesn't solve the issue that we have the group 3. We're coming to that later. So how did I build this this measure? This measure is just the sum of the budget. So this is nothing different compared to this column, the budget. This is only just the sum of the budget column. But I then used treat as, and this means treat the budget product group as there would be a filter applied on the in the current filter context available product groups. So I take all the product groups available in the current filter context. So values comes up with a list of product groups in the current filter context. That means either in these individual lines, group 1, group 2, or no filter at all, and then apply it on the product group. So with treaters, I can create a filter relationship on the fly. So it's not available in the model, but it's available only for the sake of this calculation. So with calculate, I can come up with a measure and then come up with filter context modifiers, so to say. Filters, I can change the filters, I can add filters, I can remove filters. Here we create a filter depending on what's available in the product group and apply this on the product group on the budget table. So that's the good news here. But the bad news, we don't see the group 3, right? There's one way we can build this. The other way is, maybe you say, oh, I'm new to Power BI, I'm new to DAX, this is too complicated. I have a hard time in writing this code. I have a hard time in writing the code or understand the code. Then we can still go there and then create this filter relationship between the group and not the budget, but the other group. So this will then create a many-to-many relationship. I get a warning down there. It's just a warning. I can still click on the OK button and tells me that's a many-to-many relationship. You should be aware of the consequences you're having here, and the consequences could be a slow performance and or more complicated DAX and or situations where you cannot add another table and then make it also a many-to-many relationship with a bidirectional filter, because this would introduce ambiguity to the model. In this case, I just ignore this and say, yeah, I know what I'm doing. So for some reason, this is inactive. This was not planned, so I want to make this active. And that's new. Can I create... okay, because I have to change this. I want to filter from the product table to the budget table, not a many-to-many relationship. And then it's okay again. So I have a many-to-many relationship now because the product group here and the product group here is not distinct. So there's duplicates here and there's duplicates here. But the filter is still going from the product table to the budget table. And with this change, we achieve a similar situation for the budget now. So I didn't change the calculation of the budget, but I changed the model. And the calculations are very depending on the model. As we can see, we see the same numbers for the individual lines, but you see the 60,000 here. And now it's the question, what's right or wrong, right? The 60,000 is right because that's the total of the budget. But some people could also tell us, no, the 45 is right because it's the sum of those numbers we're seeing here. The problem is we're not seeing group 3, right? So how could we solve this? And this can be done by the classical bridge table. So I close this and close up the other example, which is in here. The bridge table means that we build a table between those two, the budget and the product table. So the many-to-many relationship, I want to split into one-to-many relationship. So there's a many-to-one relationship then from the budget to the bridge table, and there's a one-to-many relationship from the budget from the bridge table to the budget, as we will see in a second. So this new approach would be creating a bridge table Can zoom in here a bit. So this would be the new situation. I still have the budget table with a filter from the date table, so everything is the same, but I introduce this product group table with a one-to-many relationship to both the budget and the product table. So between the budget and the product, we still have a many-to-many relationship, but there's something in between which dissolves everything into a one-to-many relationship, which is the preferred thing here. And if you jump back here, we can see there's a filter relationship between sales and product, but there's also a filter relationship between product and budget. And now we get what I think the right number in all situations. So we can see that the individual numbers are right. This is the numbers we can see here. Depending on the date and the product group, we see the right numbers. The sum is the 60,000. And we also see the group 3 here, because I took now from this common product group, where is it? The product group table. Over there, the product group table now consists of group 2, 3, and 1. And this is formed, I mean, you can use Power Query for that, you can use DAX for that, which I did here, or you could build this in a data warehouse, right? You could use SQL to come up with a unioned list, distinct list of those budget groups. And what I'm doing here is a distinct list of the product group from the budget, a distinct list of the product group from the product table, union them, so I take the lists underneath each other, and there could be duplicates, right? Because with product 2 we have them both, so I again wrap it into a distinct. Any questions at this point in time? How and why to form a bridge table?
No, it's clear, I guess. No worries.
Very good, very good. Then we jump forward. There's no questions here. Galaxy scheme. Funny discussions in the chat. I like that. So 3Ds, just to keep in mind, because maybe you think, I don't build any relationships now in the data model. I don't bother with that. So I just do it with 3Ds. But this is dangerous because 3Ds is using a virtual relationship, so there's no physical relationship. And if you take a look on the data model with Vertipaq Analyzer, for example, you will see that relationships occupy memory and space in the data model because there's a sort of index. Think about this, it's an index where all the combinations are formed and stored. So to make an actual filter pass through faster because this index is available. With 3Ds, there's no index because there's no relationship. The data model and Power BI and Vertipaq didn't even know that this could be possible to join those two tables. So you're building this on the fly, and the active relationship will not be envy on you, but you will have to pay a price for that, and it could be the performance could suffer. And of course, your DAX statements are much more complicated because you have to write these 3Ds in every single measure you want to use. You want to use this relationship. So keep this in mind. This is not a solution for everything, but there's some sort of situations where this comes in very, very handy. I built this for in a data model where one of the dimension tables had 1 million rows, and it was not a big of an issue with 3Ds. So your of course, your mileage may vary. And now I closed the relationship, the slides. Jump forward, detached table. So detached table is similar to what we just have seen, that there is maybe no relationship between the table. There's no physical relationship in the model view. Again, be careful with that because this could come up with a performance issue. But while I need this, the only way where I can use this is if you have complex relationships in the terms that a usual filter relationship is an equity join. So we can only apply where the product ID here is some value, and I want to find the same product ID in the other table. So the filter is on an equality expression. Product ID equals the product ID there, then I want to join those rows from these tables. If we need more complex relationships, like a range or some inequality or something, we cannot build a filter relationship in the model view, and then we can reach out for this concept I want to demonstrate next. I use this for binning. Binning means that we have values, and I'm not actually interested in the actual values, but I want to put them in different bins. Like this is a low value, this is a medium value, this is a high value, because the actual numbers is not so important at this moment when I do this analysis, but I want just get a rough picture. How many low sales, high sales, medium sales do we have, or whatever your bins might be. And there's two ways how we can model this. One, we can actually use relationships. and this is then faster, but then we have to build a table according to the different bins and different values we have available. We'll see in a second. Or the other one is then using this detached table approach, where we can just provide the low and the high range of the bin and then make sure that DAX covers for this more complex relationship. Let's jump over to the next demo. So close this, and then I don't want to save this, and we go into binning. This is in DAX, and then I have it with binning. Here we go. It's about time to up the Power BI desktop again. This week I discovered I still have the August version, and I think the November version should be out soon. So let's see what kind of model I'm having here. Again, this is the simple model, very simple model, again with the same, maybe the data is different, but it's the same idea. Like we have 4 sales with different quantities and total costs. We have 4 products, one product, there's no sales, and there's different sales for different quantities. That's what we concentrate on next, and then there's a date table. And then that's the goal. Like I want to have like my products A, B, C. That's the names of the products, and then know how often was this sold in a low, middle, or high quantity. So A obviously only was sold 1 in the medium and middle quantity. If you see here, the quantity is 3, and according to my bin table, 3 means middle. And B was sold in low and middle 2 times, 1 low, 1 middle. So as you can see here, 1 and 4, and 1 falls into the low region, and 4 is middle. And C is then in the high. Only 1 says they are high because 5, according to my table, is high. So that's the idea of coming up with an analysis like that. And we already see the first solution. So the first solution is that you could come up with a bin table, a table with all the thinkable quantities, and then assign different values to them. So this is rather, it's rather easy to build. You can just come up with an Excel file, right? And then type in 1, 2, 3, and then like add it to, I don't know, 100, and then you copy this low value for the first 20, and the medium for the next 30, and the rest for the higher whatever. So this is easy. It's not complex to maintain. It can be like awkward because it's a long list of values, but it's rather easy to do. And then we can join those 2 tables on the quantity, which is maybe an unusual idea because usually we join things on their ID, right? And the quantity is not an ID here, but we can use this. So for example, one solution here is this bin table, is that we have a relationship. I have a relationship here on the quantity. So the quantity of the sales table is something I can also aggregate on, but I also use it to have the bin table associated with that, and then I can show the bin from this bin table in my report as I just did here. So this is one way. This only works if you have a distinct list of values. So if you know what kind of values could appear, maybe for the quantity, maybe it's not always clear. We can be sure that there's no zero quantity, there's no negative quantities. Sometimes you have like if you have returns, they're sometimes in as minus. Then we would have to add this in this bin table. Maybe we know that the maximum of quantity is 10 because our system does not allow us. Then we could like provide for 10 values, or we have to be careful like here, so to apply as many quantities as there could be thinkable of. If we miss some, then Power BI and the word packaging is very forgiving. So if there's one quantity, for example, this list stops with 6, right? If I would have one sales with a quantity of 7, then this will show up with a blank product, with a blank bin. So everything which is not in this table will not be missed, because Power BI word packaging is always doing a left outer join automatically. There's no other way around that, and we will not lose this, but it will just show up with a blank. So as soon as you see those blanks, then you would have to maintain your bin table again. And the bin table can be built in various things. We already talked about DAX, show the solution in DAX here. So we can create this bin table in DAX, which means that I just go over my jump over my, where's my mouse cursor? Here's my mouse cursor. So I get the distinct layers of my quantity, and to this I then add a bin column, this add columns and adds this bin column, and that is just a switch, right? So I check if true, the first element is true, then the next will be compared to true. So if sales quantity is lower than 3, if this is true, then the content of the bin will be low. If it's like lower than 5, should also go below than 3, but the switch statement would stop here, right? If it's lower than 3, if it's lower than 5, it will return middle, and for all the other one, it would be return high. So even if we have like a value of, I don't know, 20, it will appear on the high. If it will be 0 or minus, it will be associated with low. And then I can then also add a sort order, because I want to make sure that it's not alphabetically sorted, but that it's sorted by whatever the lowest bin in there is. So of course low should be first, and then middle and high, and this is what this makes out of that. So I'm looking for the minimum value inside of the bin, like 1 or whatever the value is, and this is then associated to low. So this is the table coming up here. This table has two disadvantages. One is, looking at it is a little bit weird because there's gaps, but those gaps are no problem at all, because these gaps result in gaps in here. We don't have a quantity of 2, so I don't need it in the bin table. As soon as there's some sale appears with a quantity of 2, this will be automatically added here through the refresh. The other disadvantage is that we are now scanning for this bin table, creating this table. I'm scanning the whole fact table, and of course in this case the sales table is rather small, right? So there's no danger in that, but usually a fact table can be huge. So building up this table this way could be a bad idea if this is like millions, billions of rows. So be careful with that. So if the table is too big, and or we cannot provide a distinct list of those values, think about if it's not a quantity, or if it's a quantity but you sell goods like in kilograms or liters or milliliters. So there could be an endless number of amounts or numbers in between. And then we cannot use this, because then building this bin table would be impossible. Or the bin table would be really big, and still there could be always one value in between. So then we can jump over to the other solution. Let's concentrate on this table here. This is the bin train table, where I just provide a table, and this can also be maintained by the end user, Excel or whatever, where we say, yeah, I don't care how low it is, yeah, but if it's up to 3 and 3 is not included, so 3 is already middle, right? But up to 3, like 2.99999 would be just lower than 3, then it's low. If it's between 3 and 5, 3 is included, 5 is not included, then it would be middle, and 5 or whatever higher the number could be, I don't care, it should be in the high region. As you can see here, the solution ends up with the same result, so it's working fine. But you can also see that there's no relationship between the bin range and the sales table. How could it be? Because we are now looking for quantities which are in between the high and the low value, and there's no way of specifying something like that. So this VertiPaq engine does not allow for having a relationship which is not based on an equijoin. So we have to maintain a duck statement here. So this bin count is the values we're seeing in here. And if we take a closer look here, I'm using this sum x to count. That means I'm getting a sum x takes a filter, a table expression, and for every row in this table, whatever this expression returns, we get the value of 1, and then a sum up 1. So I'm counting. Sometimes this is a little bit faster than just applying a count. We could also have a count on this filter that will also work here. And then we have two filters. There's one filter in here, there's a filter in there. Let's take a look on the inner filter first. So the bin range table, this is this table. So this filter is iterating over this table and now deciding on what kind of row or rows it should return. So this is the bin range table, and then I have a long expression here. This is going over 3 lines, but it is connected with this Boolean AND here. So if the quantity is blank, yeah, I'm not interested, because if there's no value available, then I'm not doing anything. But if it's not blank, then I'm looking for if the quantity is bigger or equal to whatever the low range is, like if it's bigger or equal to this blank value, or if the low value is blank. This would also be okay. So if the low value is blank, it should be applied to all quantities. And if the quantity is lower than the higher value, so for example, for a value of, what do we have here, a value of 2, this will feel lower than 3, so it will fulfill this. So it would survive this condition, right? It would also survive the other one. So this line would survive the other one because it's like it's not greater equal than blank, but this thing here is blank, so it will then return low. So this expression returns then one line according to where the quantity falls into, and then this variable is checking if whatever is returned from here, if this is non-empty. If it is non-empty, then we have found a value, right? And then it is in the bin, and then we can count for this bin this value. So, hope this makes sense. If you've never seen DAX before, this might be a lot of information or a long statement here, but this is understandable. So to say, you can learn this. There's ways around it, but this makes it possible to have non-equi joins. Okay. Any questions to binning? And then a question, how much time do I have left? I think it's until, is it 10 or 5 past 10? It's like, I have 20 minutes left, all right? Is this right? 20 minutes left?
Yes.
Okay, very good. So we can concentrate on the next one. So this is, I mean, it's never enough time, right? But it's more than enough time to show you the last example about the key value. There's no question so far. Okay, so key value pair model. What is the key value pair model? A key value pair table is a table, basically, theoretically, with only 2 columns. There's a key column and there's a value column. And those pairs, that's why it's called pair, key value pairs. Pairs of those 2 columns. And the key would be an attribute. Like the key would hold a string containing name, birthday, whatever, as a string. And the value would then show the value for this key. So for example, if the key is name, the value could be Marcus. If the key is birthday, then the value should contain some date in a date format, right? Indeed, it's more than those columns. Usually you also have an ID column, which groups those ways, because maybe there's more than one person, right? And if I just have name Marcus and name Andre, then I'm not sure whose name belongs to whose birthday. Yeah. So I want to group those. So I also have an ID. So maybe Andre gets the ID 1, and the key is name, and the birthday is something. And that is an ID 2, and with name, and then Marcus, for example. Hopefully, there's also a type descriptor which tells us what's the data type of the key. So for the name, it will tell us this is a string. For the birthday, it will tell us this is in a date format or in a certain date format, maybe, if there's different date formats available. If it's the salary or the revenue or whatever, it should tell us this is a number, a whole number, a decimal number, whatever. We can be very flexible there. We come back to this type descriptor later. The thing why this can be found, or why this is used, is extremely flexible, as you can see here. Like within a relational database, which has a schema, right? We have a key column and a value column. This is a schema, but still there's no schema because the data itself, the information itself, is stored not in the schema, because I have a key, it can be of any type. Well, the key is a string, right? But the value for it can be of any type. And if there's new values, new attributes we want to store in this table, it's just easy because we just add a new line. So for ID 1, we now store whatever text paid, whatever the information is. So we don't have to change the schema. We don't have to change the table, the structure of the table. And that's why this is liked or loved by application developers, because they might think of the database just as a stupid store of data, of information. They don't care too much about like maintaining a schema. They only see the troubles in maintaining a schema, because that means that they have to roll out the application, but also have to roll out the database changes, which might be very complex. Or some applications just need a framework between the application and the database. So the application developer does not even know what's happening in the database, because it's just calls or methods of a framework they're using. So I totally understand why this is the cool approach, because it gives us a lot of flexibility. But the backdraft is, it's extremely hard to build reports on that. As we will see in the demo, usually we need to pivot this information. So instead of having a row where the key says name and then we get the name, we need a column called name and then see the actual names of all those people, of all those IDs, right? So we have to change and transform this model. First, we have to transform and pivot this table to get it everything which is in rows into columns. This is called pivoting. And on the other hand, of course, afterwards we have to rework this as a start schema. And the use case I'm coming up here or why I'm having this talking about this is an actual use case I had with one of my customers. It's about insurance, and they have an application available where, like, if you have a claim, if you say, I'm insured for this and this thing, and then they claim the insurance. I say, now I can't work anymore, so I want you as my insurer pay me all the money promised, and then they have to fill out things and forms. And depending on the answers, they might ask different questions. So they have like a rule book, which is a secret rule book. I didn't see the rule book. There's very secret, big secret there. And so the rule book might ask, I don't know, maybe 1,000 questions. So when they store the answers, they didn't come up with like a broad table with all those columns, but they decided for having this key value pairs. So depending on what kind of answers they get, they might ask different questions again. So like the list of questions and answers per insurer, per now what's it? It's a patient. What's the term in English? I can't remember. So the one who claims the insurance, the claimer, might be different. And they didn't want to change the schema. And this is so flexible that it even, if I look at the data currently now, it does mean like we have like 800 attributes or keys available there, but tomorrow there could be another attribute there again. And when I started with this project, I just began with like defining a table with 800 columns and pivoted everything. And once in a while they asked me, there's some information missing because there's new attributes coming up, and then I had to like rework the model, change the data model, change all the ETL process, change the views, change the model analysis services, and change the report to also show this information. And at some point in time, I decided this is not scalable, right? I mean, I love to be engaged and like have work, and I can bill hours for all this work, but this is not scalable. I want to build up a solution which is do this more automatically. And this is what I will demonstrate here. I think for today I will show like the solution in Power Query. 50 minutes left. In Power Query, actually for the customer, I built this in SQL, and also for this kind of demonstrations, I also have the same available for DAX. But I think today we stick with Power Query. That's what I decided on here, and which does this semi-automatically or even automatically. So creating all those steps in between and doing all those pivoting. But let's see what we're coming up here with. Again, close this demo file, and then no, not saving anything. Then we jump up here to the key value, and then we have the key value example. Yeah, 800 columns, yes. And it's ever growing. I mean, this is just at the very moment, and tomorrow it could be 805. How do you make your model on the 800? It's too much to manage. No, actually it isn't. Yes, that's I also was afraid of that, like having a table with 800 columns, but it's working. It's working fine. It's analysis services, and the performance is okay. I mean, we're not reporting on all of them, so there's mostly the measure is counting on things. So they want to know how many people claimed because of knee problems or back problems or mental issues or whatever. So we're mostly counting on things and setting filters on those attributes. And on top of that, it's also a multi-language model. So we had like to, I also came up with, for the same customer, that like the report viewer can change the language they want to see the report in. So all the headers change, but of course also the attributes change. So knee problem in English is a different term than knee problem in German, as you might guess. So depending on whatever language they choose, to be sure either knee problem or Knieproblem in German or other language. So it's a rather complicated model, but performance is fine. It's okay. Yeah, 799 would be okay, but 800 is just too much. Yeah, I mean there has to be a limit, right? There has to be a red line. And 800 is just too much. I totally understand. Yeah. So let's take a look on this table. So this is this key value table, as I just tried to describe in words. Now we see this key city, for example, value Seattle, key first purchase, and then we have a date in here, name, and then I group those by different IDs. So obviously this is a different person from this person or from the other person. The cool thing I discovered here, I never thought about that, because usually I get it like already in columns. I don't get it in lists, or like up to this point, I didn't have those challenges that much. What we can do here is that we can come up with a matrix like this. So I really like this idea. Now I even have this like in my book, so to speak. This was the wrong thing. I wanted to click like that. So zoom in here. So what we see here is that I get a matrix here where I see the names here. So for the rows, I selected names. So I see there's different names. For the columns, I see the different cities, Arco from Seattle. I see the totals again. And then we see counts. So I don't see like what they earned, but I see counts here. But with this kind of model, with this key value, as everything is in rows, I could put things up there. So can I, for example, change or add the first purchase here, or remove the city here. So I, as a user, can now change the look and feel of this table, what kind of information I want to see here. Or I could just add, for example, the name, and then also the what do we have here, the city down there. So now we see, like in Arkoven, we had one sale on this date, and there's one Marcus also sold some, bought something on this date. So this is rather flexible. And building up this, I increased my problem of having this one key value pair model or table. I have two of them now. So for this, I used one slicer on the key column of the key value pair, right? And then I duplicated all the information, did a filter on the key of the other source table here, the key value pair model, and here I use the values either from the one table, source 1, or the source 2, and then count the IDs of one of those tables, and I combine them in a data model with a many-to-many relationship with bidirectional filters. So it always gives me a heart attack if I see what I did here, but if the table is not too big, the performance is also nice, and this gives for really flexible reports. But that's not the usual thing, right? Usually we have to build up something like that. I want to have all my customers, whatever. I want to see the attributes. I want to see the revenues and so on. And the backdraft here, as you can see here, there's like the revenues left assigned. This is all unusual, right? Because the revenue is a string. Everything is a string. The value column, there's one column value, contains all the values, right? And the thing in common for everything is to have it as strings. So if I could add a total here, but the total would not allow me to sum something up to show like the minimum value or whatever. So this does not work. We have to do something here. And I think we jump to the Power Query, because I think the Power Query is the most useful here. So with Power Query, I managed to get actually the revenue as numbers, see the total down there, and get the different date types right. And let's see what I've left with this 10 minutes I've got. So let's jump to Power Query Editor. So the source table is the source table as I get it, like the ID, the key, the value, and the type. The type is not very important. What's the content of that? Here, I use the data types of Power Query, but this could also be like 1 means text, 2 means whole number, and 3 means date. It's not very important because we can react to that. I just wanted to make